let's try to find the limit of the function 5 plus 2x over 3 minus x as x goes to infinity. What this means is we are trying to figure out what is the end behavior of this rational function. Namely, what happens, is it going to grow infinitely big? Is it going to just become infinitely big and negative? Or is it going to approach some sort of constant number? That is the question we are trying to answer with evaluating this limit, by evaluating this limit. So here we have a rational function where we have a polynomial divided by a polynomial. The best thing to do in these cases, so whenever you're dealing with a rational function, is to actually use a trick, namely to divide through top and bottom of the fraction by the highest power of x that is present anywhere in the fraction. So in this case that's an x, so we end up with a 5 over x plus 2x over x. Notice that this Notice that now all I have is basically done is I divided through the numerator by x. Then I'm going to divide through the denominator by an x, and also just write these as separate fractions. So now I'm going to simplify, and I'm going to end up with the limit as x approaches infinity of 5 over x plus a 2 divided by a 3 over x minus a 1. And now basically what we're able to do is just calculate the limit of the top and the limit of the bottom separately, and things are going to be okay and valid as long as those limits exist, and as long as the limit in the denominator is not 0. So let's see what happens. Here we basically end up figuring out what is the limit as x goes to infinity of 5 over x plus the limit as x goes to infinity of 2, all of it, divided by the limit as x goes to infinity of the fraction 3 over x minus the limit as x goes to infinity of 1. Okay, so this is again an intermediate step that once I'm used to and once I know what I'm doing, I don't usually write down. But what happens now is I'm interested in now just the limit as x goes to infinity of the fraction 5 over x. What happens here is that that thing is going to become 0. That is because what happens when 5 is divided by a larger and larger and larger number? Well, the number will tend to become smaller and smaller and smaller, so the limit itself will be 0. Plus, here we have a limit as x goes to infinity of the constant 2. Well, 2 doesn't change no matter what x does. So now in the numerator we have a 0 plus 2. Limit as x goes to infinity of 3 over x is again 0. And then we end up taking the limit of a constant as x goes to infinity, so that is going to be unchanged. So altogether we end up with a 2 over negative 1, which is a negative 2. So that means that what does this limit equaling negative 2 mean? Well, it means that as x goes really big, the rational function's value is going to get closer and closer and closer to negative 2.